ലാപ്ലേസ് ട്രാൻസ്ഫോംസ് എന്ന് പറഞ്ഞാൽ ഒരു ഫംഗ്ഷൻ എഫ് ഓഫ് ടി ഗ്രേറ്റർ ദാൻ ഓർ ഈക്വൽ ടു 0. This is a function of t and the domain is the values of t that are t greater than or equal to 0. That is 0 and positive real numbers or non-negative real numbers. Or t takes the values from 0 to infinite. Then we define Laplace transform denoted by L, this type of L, and a curly bracket. L of f of t is equal to integrating from 0 to infinite, values of t, 0 to infinite, e raised to minus st into f of t dt. This is the definition of Laplace transform. Here we transform a function f of t into another function by this rule, that is an integration. In that integration, we multiply f of t by e raised to minus st and integrating from 0 to infinite. Integrating with respect to t and finally giving upper limit for t infinite minus lower limit for t equal to 0, then t vanishes. After giving values for t, then no t remains there and the only remaining variable is s. Therefore it will be a function of s and we denote it by capital F of s. That is L of f of t is equal to capital F of s. Okay, this is a Laplace transform of a function small f of t and transformed function is capital F of s. Okay, if we use some notation, another notation, if g of t is the given function and finding Laplace transform L of g of t, we may write that by g of s. Or if we take L of some function h of t, then we may denote this value by capital h of s, function of s, etc. Okay, we can see some standard result. What is Laplace transform of 0? What is Laplace transform of 0? Then at once the formula is, instead of this f of t, we give value 0. Then it's integral 0 to infinite e raised to minus st into 0 dt. And this is integral 0. Integral 0 to infinite 0 dt. And integral of 0 is usually constant because derivative of constant is 0. Therefore integral of 0 is constant. But giving two limits, upper limit infinite and lower limit 0, then first is this upper limit infinite, then c minus lower limit 0, again c, that is 0. That is Laplace transform of 0 is 0. So result, standard result. Likewise Laplace transform of what is 1? Again by formula integral 0 to infinite e raised to minus st into 1 dt. Then what is integral of e raised to minus st? Integral of e raised to exponential function is same. E raised to x is integral of e raised to x is e raised to x itself. Therefore integral of e raised to minus st is e raised to minus st. But the derivative with respect to t, that is here minuses, we have to divide it by minuses. When integrating, we divide by the derivative. For exponential function e raised to, the integral is same, but for minus st the derivative is minuses with respect to t and we divide by minuses. And to give the limits, that is first we have to give the limit infinite minus then 0. Then we have to give the values for t. Then this s is independent, no need to give value for s. Then we can take this outside, 1 by minuses or minus 1 by s we take outside. And giving values for t, first e raised to minus s into infinite minus, then the value for t is 0, e raised to minus s into 0. What happens? It is minus 1 by s into e raised to minus infinite. E raised to minus infinite, minus s into infinity is minus infinite. E raised to minus infinity is 1 by e raised to infinite. Okay, minus e raised to 0 here, that is 1. 1 by e raised to infinity. E raised to infinity is again infinite. Then 1 by infinity is 0. Okay, then answer is minus 1 by s into 0 minus 1. That is equal to 1 by s. Okay, that is Laplace transform of 1 is 1 by s. This is a method to find Laplace transform. Suppose we are asked to find Laplace transform of t. Then we take the integral 0 to infinite e raised to minus st is common into this t, f of t, that is t dt. Okay. Then we have this function, two functions of t, one is t and another is e raised to minus st. Then to integrate we have to use product rule. Take first function as t and the second function is e raised to minus t. And what is the rule of product rule of integration by parts? First function into integral of second. Integral of second is e raised to minus st by minus s. And to give this limit 0 to infinite. That is first function into integral of second over and given the limit minus integral of derivative of first. Derivative of t is 1 and integral of second is this same is written here, minus st by minus s dt. Okay. This is a product rule for integration or integration by parts. Here we are taking first function as t and second function as e raised to minus st. What happens? First function into integral of second. Integral of e raised to is same, but derivative of minus st with respect to t is minus s. We have to divide it by minus s. Okay, and after that giving values 0 infinite minus integral of derivative of first function, that is 1. Integral of derivative of t is 1 into integral of second is same. This taken into this. Okay. Now what happens? Again we can take this independent of t ഇല്ലാത്ത ടേം, അതായത് -1/s പുറമെ എടുക്കാം. ബാക്കി എന്താ വരിക? ടിക്ക് ഇൻഫിനിറ്റ് ആദ്യം കൊടുക്കണം. ഇൻഫിനിറ്റ് ഇൻറ്റു ഇ റേസ്ഡ് മൈനസ് ഇൻഫിനിറ്റ്. ഓക്കെ, മൈനസ് എസ് ഇൻറ്റു മൈനസ് ഇൻഫിനിറ്റ് മൈനസ് 0, പിന്നെ ടിക്ക് 0 ഇൻറ്റു ഇ റേസ്ഡ് 0. Okay, again here is a minus, that is plus 1/s outside integral 0 to infinite e raised to minus st dt. Okay, to integrate with respect to t we can take other variables s outside, no need to put s here. We take s outside, it is minus 1/s outside, then plus 1/s. Okay, and here it is 0, 1 by infinity is 0 and it's also 0 and the first term vanishes, and for the remaining 1/s into we are again find the integral e raised to minus st by minus s and giving the limit for that 0 infinite. Again 1 by minus s is here independent of t, no need to give values for s here, we are giving only values for t. If I take this 1 by minus s outside, then that is already 1/s outside, so we are getting total minus 1/s square outside, and again value minus infinity, that is e raised to minus infinity minus e raised to 0, and this e raised to minus infinity is 0, 1 by e raised to infinity is 0, and e raised to 0 is 1, that is 0 minus 1, and minus 1/s square value is 1/s square. Okay, this is the Laplace transform of t. This is a method to find the Laplace transform of any function, given function. Find the Laplace transform of some function may be given, and the method is to find, use the formula L of f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. Okay, thank you.